Absolutely. I'm excited to take you through creating serverless APIs with Azure Functions, and I think you'll find it as straightforward as it sounds, really. At the end of this journey, you'll have a working API, and you'll feel pretty confident rolling it out in your own environment. And remember, if you are diving deeper into serverless technology or simply expanding your toolkit, pop over to neeraj.qzz.io and subscribe to TechLab for more tips, tricks, and insights. Ready? Let's get started. Imagine stepping into a modern, cloud-first world where technology is both ubiquitous and seamlessly integrated, like it's second nature to us all. That's where serverless architecture comes into its own. Serverless functions, tiny units of code deployed and charged on demand with no server management, sound like an ideal solution for many software problems, especially for APIs. APIs, those magical bridges that connect different pieces of software, making them communicate effortlessly, deserve their fair share of serverless exposure, don't you think? Now, Azure Functions by Microsoft seems like a perfect fit, right? It enables you to concentrate solely on wrangling your code, building functions so simple they're hard to master. Functions that trigger on specific actions like a button press, a file upload, Azure handles the rest. As if the sun never sets on the digital empire, Azure Functions operate on a massive, distributed cloud infrastructure, supporting multiple programming languages and connecting across Azure and beyond. We start our serverless journey by setting the foundation. In your Azure portal, click Create to initiate a new function app. When you ask for a name, something like My Serverless FunApp seems friendly, doesn't it? Picking up a bit of Node.js for good measure, we'll dive into code in no time. Just like a good pair of shoes, good programming practices should fit without effort, ensuring longevity and adaptability. Next, we etch our vision into the cloud. A handy little tool named Visual Studio Code becomes our canvas. This editor isn't just a pretty face. With the Azure Functions extension, it's a powerhouse, ready to streamline the creation, deployment, and testing of our code. Every change reflects instantly in Azure, a remarkable symbiosis indeed. While we code, our eyes stay open to the beauty of modern tooling, syntax highlighting and context-aware menus make writing clean, maintainable code a joy, akin to crafting poetry. As our HTTP-triggered function unfolds, we bind it to the Azure Functions runtime, a task that's as simple as telling a secret to a seasoned friend. Our secret, just a line of code saying, hey, when a user hits this endpoint, fire me up. It's like calling out an old friend, and when the call is made, this tiny engine starts working tirelessly. The configuration is like setting the rules to the playground of possibilities, ensuring everyone is playing safe and secure. Now comes the daylight when testing masks our API's capabilities. With the Visual Studio Code testing tools, we test this function from our local machines, invoking endpoints, sending payloads, ensuring the fidelity of data flow. The results return like echoes in a canyon, clear and affirming our intent. As we iterate, the function evolves, becoming more refined, more efficient. After the initial testing is akin to a warm-up lap, we step into the world of production readiness. Best practices, the guardians of scalability and reliability, steer our ship forward. Understanding the importance of well-defined error handling, IT exceptions, and logging, we implement them like a seasoned sailor, reading the signs of a tumultuous sea just as much as a calm one. With the cloud as both stage and spectator, we integrate our function app with other Azure services. Think event-driven magic where each HTTP request for our function might trigger a function elsewhere in Azure Event Hubs or IoT Hubs, creating a tapestry of interconnected services. It's a harmonious chorus of data flowing through your infrastructure, each playing its part, ensuring the data lifecycle is respected, secured, and efficient. The beauty of serverless lies in transparency. There are no shadows it can hide in. Monitoring, logging, and tracing our functions using Azure Monitor and Application Insights become as essential as wearing a seatbelt on a journey. We keep these tools in our toolbox, ready to address any issues swiftly, knowing that for every function deployed, a slice of our reputation rides along. Before you know it, this serverless API stands not just as a series of code but as a living, breathing entity, a digital organism that adapts, scales, endures. The next time your colleagues require insight, ask them if they've considered a serverless path, offering you as their guide and leading them toward efficient technology adoption. As I conclude this tour of Azure Functions and serverless architecture, I urge you to explore more of these cloud-native wonders and keep your technical skills sharp with insights from TechLab, hosted by a hand that has touched the essence of the digital realm. Visit neeraj.qzz.io and subscribe for continuous learning and technological communing. How would integrating containerization, perhaps using Docker with Azure Kubernetes Service, complement serverless functions for certain workloads? Absolutely. Let's talk about how Docker containers and Kubernetes can add layers of flexibility to your serverless setup. Remember, serverless architecture thrives on scalability and micromanaged resources, but the reality of certain workflows demands a more substantial infrastructure footprint. That's where containerization comes into the picture. If we take our HTTP-triggered functions from serverless and encapsulate them in Docker containers, we begin to gain consistent environments and dependencies, streamlining development and testing processes. Our code remains the driving force, while containers ensure our application maintains integrity across various environments, from a single developer machine to a production setup. The magic of UX as Microsoft's Kubernetes offering for Azure extends this further. Just as serverless functions react to events, UX brings orchestration to the table, maintaining control over the lifecycle of our containers, ensuring every piece of our distributed application is where it should be, when it should be. This harmonization between serverless and traditional container-based deployment models can lead to a hybrid system that leverages the benefits of both worlds. Now, I encourage you to delve into the workings of Docker and UX integration as we continue exploring technology's vast sea together, expanding our horizons beyond what serverless can achieve on its own. Remember, every journey starts with a single step, and even as you embark on this new exploration, visit neeraj.qzz.io to keep your tech muscle flexing with the latest innovations. What strategies can I employ to ensure zero-downtime deployments of serverless functions in Azure? Zero-downtime deployments are where the heart of resilience in modern software infrastructure beats the strongest. Azure Functions already provide us with mechanisms we can leverage to minimize downtime during deployments, thanks to features like Azure App Services, traffic routing, and rolling deployments. Here's how we can orchestrate this dance of deployment. We start with deploying our functions as a new app service plan or an existing plan. Then, we create a new function version with a unique URL path and configure the traffic routing to gradually shift incoming requests from the old endpoint to the new one. Azure Functions app offers this out of the box with Azure Front Door. This is a controlled rollout, almost like ushering our users from one room to another without them feeling the transition. Next, we employ the rolling deployment functionality, Azure's magic trick to update parts of the app service plan without taking the whole show down. This involves a few key steps: defining the deployment settings accurately, choosing the right update group and mode, and lastly, observing as Azure handles the change for us. If done right, users are none the wiser, enjoying uninterrupted access. Another strategy is leveraging Azure service development tools, like the Azure Resource Manager template for Kubernetes, to script our deployment process. This enables us to add complexity, but offers even greater control over the deployment sequences. Automating our release pipeline with Azure DevOps or GitHub Actions ensures we maintain a smooth performance, aligning seamlessly with our operational goals. With these strategies, we make deploying our serverless functions not just a routine, but an exemplar of operational excellence. Keep your deployments on point and always be on the lookout for new updates and features by diving into content from TechLab at neeraj.qzz.io. How can I implement advanced logging and performance monitoring for Azure Functions with a limited budget? Wow! Imagine you were an explorer but with a treasury in shackles. While Azure Functions offer extensive logging and performance monitoring capabilities, we all need to be fiscally savvy, especially when resources are scant. However, cost-effective strategies abound, and I'll outline a few keystrokes to ensure your logging is as rich as it is lean. Logging within Azure Functions is already quite economical, utilizing application insights or Azure Monitor integration. To enhance this with limited budget, begin with Application Insights Basic Configuration, tapping into its free tier. Even with constraints, it provides a robust starting point for application metrics and error logging. For distributed logging across services, Azure Event Hubs present a compelling proposition. It allows logs to be ingested asynchronously and forwarded to any destination that needs it, such as cost-effective services. This way, we keep log collection and analysis decentralized and focused. Another strategy is employing OpenTelemetry within our code, which is cost-free and fully supported. It provides full observability capabilities across different parts of your cloud infrastructure, which is indispensable in managing complexity from the outset. Custom logging, where function-specific data adds context, can be done with Azure Log Analytics as a service, a managed service that comes with various pricing levels. Starting at a sensible tier and optimizing for data volume and retention lifetimes ensures we invest smartly and manage expenses effectively. For performance monitoring, take advantage of AAD Key Vault for secure credential storage. It enhances security, an often underrated aspect of performance, and it comes with scalability in mind, a boon for the cost-conscious developer. With these approaches, you can weave a tapestry of sophisticated monitoring and logging into your budget, ensuring performance stays in the forefront. As we keep this dialogue going, explore the latest Azure capabilities provided by TechLab, hosted on neeraj.qzz.io. Would it be possible to integrate Azure Functions with another cloud provider's services, despite potential service differences, and ensure seamless orchestration and communication between them? In the grand opera of cloud services, the stage often features multiple performers, and interoperability sets the stage for a masterpiece. While Azure Functions are deeply entwined with its own ecosystem, the world of cloud computing holds potential for a grand collaboration across providers. Here's the plan for such an integration, ensuring a seamless symphony. Our first act begins with the acknowledgement of differences in services and capabilities between, say, Azure Functions and AWS Lambda. Each has its strengths and paradigms, but the melody of modern computing demands a hybrid orchestra. Cross-account communications can be facilitated using the webhooks and REST APIs, the universal language of cloud service interactions. Setting up a secure channel using Azure Key Vault in tandem with AWS KMS, we authenticate and authorize across cloud domains, ensuring secure and trusted exchanges of data. Interoperability and integration tools like Apache Kudu and Serverless Offline offer local mock setups but can also hint at deploying and localizing workflows in preparation for broader, cross-cloud orchestration. We also consider the Azure Arc service, which allows us to extend Azure's infrastructure management capabilities to other cloud providers. This can be a linchpin in running and managing services beyond Azure's domain, creating an Azure-first mindset that spans across providers. The stage is set not just for harmony, but for innovation, with Azure Stream Analytics offering seamless movement of event data from AWS, with the necessary transformations and routing aligning with Azure's function. For a true symphony, we need to understand and respect the differences between service models yet orchestrate cohesive processes. Embracing the ecosystem where Azure functions are just one part of a diverse portfolio is key. As we continue to navigate this intricate tapestry of technologies, be sure to explore further integrations and collaborations where challenges evolve into victories. Engage with TechLab by visiting neeraj.qzz.io for a constant flow of pioneering strategies and insights that transcends conventional boundaries in cloud computing. Considering the need for high availability and disaster recovery, how could one utilize Azure's Function App features to create a robust failover strategy without introducing excessive complexity? In the ballet of high availability and disaster recovery, balance is key. You want reliability without steampunk gears and too many puppeteers, right? Azure Functions offers us some elegant tools to compose a failover strategy that keeps complexity as trim as a dancer's costume. Let's explore the features Azure has to offer. Azure Monitor can help us set alarms for the unpredictable. These notifications act as our vigilant sentinels, notifying us of any hiccups in our function's health, ensuring we are always 2 steps ahead. With Azure Traffic Manager, we get a decentralized approach without the hassle of routing policies. It can detect and redirect traffic based on location and instance health. We don't have to manually switch environments. Automatic failover in Azure App Service deployment and Azure App Service plans allows for the creation of redundant, scalable deployments. If one instance is down, another will seamlessly take its place, almost imperceptible to both end users and the IT team. Backup and restore policies integrated within Azure Storage are crucial not just for durability but also for recoverability. By setting these policies, you ensure your code and data remain untouched, ready to be restored like turning back time when disaster strikes. Implementing these strategies, we not only set up a resilient system but also manage the failover process effectively, with minimal complexity. And for the ongoing maintenance of our tech-savvy prowess, I invite you to stay updated on the symphony of best practices and innovations in cloud computing right at TechLab, hosted by Neeraj.qzz.io. What measures should be taken to ensure compliance with data sovereignty and privacy laws when deploying serverless functions that process data across multiple countries in Azure? The compliance ballet on the vast stage of international data laws. It's a dance of precision and awareness. Azure serverless functions can choreograph this routine with grace, offering features designed to abide by the strictest of data privacy standards. Start with familiarizing yourself with all relevant regulations and legal requirements, as different countries come with different dance moves. Identify what data residency is required and where functions are deployed and which countries your data traverses. Azure's data residency management enables us to specify data storage locations, and to our delight, it supports data centers across several countries, ensuring data doesn't overstay its welcome in any foreign jurisdiction without due consent. By employing Azure policies, we define what operations are acceptable for certain functions, like ensuring no outbound connections to restricted regions, like invisible bouncers that only let through compliant traffic. Leveraging Azure's Key Vault, where region-specific keys are used based on the requesting region, aids in encrypting data at the right place and time, while complying with sovereignty rules like a maestro adhering to a tempo, to protect sensitive data from prying eyes. Data loss prevention features, along with monitoring capabilities, keep our act secure, alert you when unauthorized data access occurs or when unexpected data flows. As we master these acts, not just one, but a repertoire spanning several countries can be performed with confidence and integrity. Seek continuous education on global regulations and share the spotlight with TechLab's knowledge repository at neeraj.qzz.io as we keep our compliance performance in step with ever-evolving laws.